Good morning. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today, eventually we're going to go to section 9.2, but I had a whole bunch of requests on email, so we'll go through those first. Okay, so this is from section 9.1, number 18. It says, simplify the expression, assume that the variable is unrestricted, so it could be positive, negative, or zero, and use absolute value symbols when necessary. All right, so we have the following. We have the square root of b squared minus 6b plus 9. Well, I can take the radicand inside there, b squared minus 6b plus 9, and it factors into a perfect square trinomial. So then this becomes that. Oops. Well, the square root of b minus 3 squared is b minus 3. However, we can't stop there. Because b is unrestricted, b could be positive or negative or zero. And when you take an even root, specifically in this case, a square root, you can't get a negative number. We need to have absolute value bars around the answer. So that was the missing piece on that one. Okay, next up is 23. And let's see here. Sorry, somebody's phoning me and I'm ignoring it. Okay, this is 9.1, number 23. It says, find each function value if possible. Do not use a calculator. If an answer is undefined, enter undefined. Okay, so we have h of t equals the square root of t squared plus t minus 8. Part A says h of negative 4, which would be negative 4 the quantity squared plus negative 4 minus 8, which would be, well, let's see, negative 4 times negative 4 is 16 plus negative 4 minus 8. 16 plus negative 4 is 12, minus 8 is 4. So we get the square root of 4, which is 2. Okay, so that's the first answer. Then the second one says, find h of negative 1. Which would be the square root of negative 1 the quantity squared plus negative 1 minus 8, which is the square root of, well, negative 1 times negative 1 is 1. 1 plus negative 1 is 0, minus 8 would be the square root of negative 8, which is not real. Now, I don't necessarily agree with the author of this book about this, but I'll tell you what they do. I say it's not real. They're saying it's undefined. I tend to think of undefined as just dividing by 0, but the directions say if an answer is undefined, enter undefined, and they're calling this undefined. So undefined. Okay. So if you put in not real, it won't accept it. But if anyway, any questions about that? Okay, number 24. In same section. Use a calculator to find each function value, round to the nearest 10,000th. G of x equals the square root of 9 minus 4x. Part A is g of negative pi. So that would be the square root of 9 minus 4 times negative pi. which would be the square root of 9 plus 4 pi. Negative times negative is positive. So going to the calculator, I'm going to put in, let's see, second, and the square root, which gets me that, 9 plus pi. And as we talked about, well, pi is over here on this column. There's a pi. So I've got 9 plus 4 pi, and then close it up. Push equals. I get 4.64396066. It said round to the nearest 10,000th. This is the one, excuse me, the tenths, hundredths, thousandths, 10,000ths. So we go one more place, the 6 would round up. So we would get 4.6440. All right. Part B says find G of 0.5, which would be 9 minus 4 times 0.5, which is the square root of 9 minus 2, which is the square root of 7. And if we take the square root of 7, we get 2.64575131. The 5 would round up, so 2.6458 would be the second answer. Okay, that takes care of one person's answers. Hang on, we're going to look at another. Let's see here. I've actually got 4 different people that had questions today, which is just great. Let's see. One. Number 18.
Mr. Mayo, I also have a question.
Okay.
A couple of them.
Sure. Go on one of the ones we just looked at, or you have something new you want me to look at?
I don't actually have it like for solving the question. On questions 16, 17, 18, and 33, when I put the absolute value signs in them, it says your answer includes 2 characters that cannot be graded.
Okay. Hold that thought, Madison. Let me get through all of these questions that people asked about. And then if I go on, you stop me and remind me, and we'll take a look and see if we can figure out what's going on there, okay?
Okay.
Let me finish this and then we'll get to you, absolutely. But do remind me in case I forget. I've been known to do that on occasion. So this is back to 9.1. This is number 18, similar to the one that we looked at before, but not the exact numbers. It says simplify the expression, okay? Assume that the variable is unrestricted and use absolute value symbols when necessary. So here we have the square root of b squared minus 18b plus 81. That factors into a perfect square. So our answer is that, except again, we need absolute value bars. Okay. So very much like when we did a minute ago. Okay. Somebody asked for one, but they've got it correct. Oh, I see. It's down below. Okay. I'm going to share this one on the screen here. All right. See number 28 there, it says complete the table. Can you see that all right? Okay, great. So they've got the table correct, but then it says graph the function. And it turns out being this one, but their question has to do with the domain and the range. All right, so take a look at this graph here. This going to the left, it's going up and it's going over. You see that? Or I should say it's going over and it's going up. And here it's going over to the right and going down. So your domain, this continues to the left forever. This continues to the right forever. So your domain would be all real numbers. Can you see down here? They put negative infinity to 0. It's in fact negative infinity to positive infinity. Does that make sense? Yeah, okay. Then the range. This is not only going over, but it's going up as well. This is not only going over, it's going down. So as this keeps going down to negative infinity and this goes up to positive infinity, excuse me, your range is also all real numbers. Okay, so that's the deal with that. It should be all real numbers for both the domain and range. 29, same thing, graph the function. All right, so they've got the right function, this, but again, and the way they graph this, they don't put arrows on it, but if it goes out to the edge of the graph, that implies it continues. So this is going to the left and down. This is going to the right and up. So your domain goes all the way to the left, all the way to the right, all real numbers. Your range goes all the way down, all the way up, all real numbers. So again, your domain and range should be negative infinity to positive infinity. Okay, and then finally, number 38. Yes, and this is that one that I looked at this with the Math 93 class, and it's like there's something missing there, because it says, oh, use a calculator to solve the problem, but there's no function to plug it into. So I think that WebAssign is lacking something here, but we're just going to do it, and don't panic. If something like this is on the test, I will accommodate such things, but we're supposed to look at 230 feet. So this is 200, 220, 240, 260, 282, or 300. So 230 would be right there. Wait, right there, okay? So dry pavement would be about 75, okay? And then wet pavement would be about 47 or 48. And again, since you've got, you can keep trying answers, you can, try and guesstimate and guess it. But yeah, I'm thinking that there's supposed to be some kind of a formula there that we're using, because it says something about rounding to the nearest whole number and using a calculator. And anyway, that's what's going on with that one. So don't panic if you had trouble with that one. Okay, I'm going to stop sharing that. Go back to this. And I need to find another person's questions. Okay. One. This is 38. Yeah. Same thing. Maybe I just need to take that out of the assignment list. So again, 250 feet. So you've got 220, 240, 250. Dry pavement looks to be about 77 or 78. Wet pavement looks to be about 50. I would actually say 52. They're saying 50. But again, I'm not sure how the person came up with these values, but again, careful with the scale, okay? Each of these little hash marks is 20 units. So 250, 220, 42, 50 would be right there. Okay, that takes care of that one. One more person, and again, it's the same question. So let me find that person's one. And number 38. Okay. All right, so 240 feet, so 200, 220, 240 would be right there. So wet pavement, it's going to be, I would say 50. They're saying 49. And here I'd say, yeah, it's about 77. So again, don't freak out over that one. There must be something missing, and there shouldn't be any issues come test time on that one. Okay. All right, now. Madison. Let me pull up your homework, Madison. And this is where, what section? Is it?
This is 9.1.
Okay. Come on. And we're talking about questions, what, 15, 16, or 16, 17, and 18?
And 33.
Okay. Let's take a look at 16, 17, 18, and then you remind me about 33.
The thing is that I think I got the right answer. It just won't, like, Cengage won't let me put in the absolute value signs for some reason. It says it's wrong.
How did you put them in there?
I found the absolute value sign online, copied and pasted it.
Okay, okay. So, tell you what, okay, you wanted 16, 17, 18. I'm going to come back to that. What was the other one?
33.
Okay, let's take a look at 33. And then, oh, it's the same thing. Okay, all right. So hang on. Okay, so let's go to student view and let's see here. Let's find some problems where we're going to use absolute value. Okay. So take a look at, for instance, problem number 16. All right. Can you see it there? The square root of 16t squared.
Yes, I can see it.
Okay. So the correct answer is going to be 4 times the absolute value of t, right?
Yeah, that's what I put.
Okay. You can't cut and paste off the internet. What you got to do, you click on the box and oh, look over here. Okay. So, oh, there's absolute value. And
Okay, thank you. I copied and pasted the infinity sign and it worked, so I don't know.
I don't know. But again, the infinity sign, everything that you need is over here, but sometimes you have to click on, for instance, there's the infinity sign right there. Okay. So you may have to click through those to find them. All righty. So does that take care of all your issues, you think?
Yeah, that does. Thank
Okay,
you.
great. All right, Madison, great. Okay, so we'll go back to just looking at my whiteboard screen and we'll go on from there. Okay. So what we're going to look at today is, oh, Madison, your microphone's still on, so.
Oh, sorry.
That's okay, not a problem. Just, all right. So what we're going to look at today is basically exponential rules, which would have been back in chapter 5, which you would have covered if you took Math 85 or maybe a beginning algebra course in high school somewhere. But we're going to apply them not just to integers, but to fractions. So we're going to have exponents that are fractions, okay? And basically what we've got is this. Let's say we're talking about the cube root of 8, all right? To write that in exponential notation, that would be 8 to the 1/3 power. So what happens is the index of the radical becomes the denominator of the exponent. So the cube root of 8 is the same as 8 to the 1/3 power, okay? Or let's say I've got the square root of 4. That would be 4 to the 1/2 power, because recall there's an implied 2 if there's nothing written there, okay? Square root. Now, let's jump to the calculator for just a minute, and let's take a look at this problem. To get the cube root of 8, on the calculator, I'm going to turn the calculator on. Well, maybe. Okay. I'm going to push the second button. Then I'm going to push the key that has a little caret, and above it, it has the X root. Okay. And so what shows up is this thing, except to use that, I have to put the index in first. So I'm going to clear the calculator. I'm going to put in 3, then the second button, then the X root. So now what I've got, it looks like this. Then I put the number 8 in there and push enter. And I get a 2. So this is not 3 times the X root. In the calculator, you have to put the index in before you access that button, okay? So the cube root of 8 is 2. Now, how would we do that using this notation? Well, I'm going to put in just a plain old 8. Then I'm going to use the caret key, not the second function key, but just that little caret. And then parentheses 1 divided by 3. And I should get 2. Now, if you don't put the parentheses in there, you're going to get that because the calculator thinks that that's the exponent, so that you've got 8 to the 1 power divided by 3, which would be 2.6 repeating. Okay, so you've got to group or parenthesize that exponent in that context. Any questions about that? Okay. Now, so this whole idea, x to the 1 over n power equals the nth root of x. And again, n has to be a positive integer greater than 1 because you know your index has to be 2, 3, 4, 5, 6, etc. All right, now, let's see, what do I want to do? Yeah, we'll talk about that here in a minute. Let's take a look at some rules and what you might want to do if you start to get into this assignment and you're really getting bogged down. Back in section 5.2, and I think it's on page 360, let's see, is it 364? On page 364, at least in the regular textbook. So page 364, section 5.2. It has all of the rules, the properties of exponents. I'm going to be reviewing them as we go, but if you want a more extensive review of them, okay? Now, let's take a look at this problem. 81 to the 1/4 power. It says evaluate each expression, okay? This is the same thing as the 4th root of 81. Now, you could do this by hand. You could say 81 is 9 times 9, 3 times 3 times 3 times 3, 3 to the 4th power. The 4th root of 3 to the 4th power would be what? 3. Or you could use a calculator and you could put it in this way and say what? 81, then the little power key, parentheses, 1 divided by 4, close parentheses equals, and you should get a 3. Okay, you could also go 4x root of 81, and that should also give you a 3. Okay, what about this one? Let's see, negative 216 to the 1/3 power. So that's the same thing as the cube root of negative 216. Now remember, you can, yes, you can take an odd root of a negative number. You just can't take an even root. So negative 216 is negative 1 times 216 is negative 1 times 2 times 108, negative 1 times 2 times 2 times 54, negative 1 times 2 times 2 times 2 times 27, negative 1 times 2 times 2 times 2 times 3 times 9. And this is getting crazy, I know. So what do we got? We got negative 1 times 2 cubed times 3 cubed. Well, the cube root of -1 is -1. The cube root of 2 cubed is 2, and the cube root of 3 cubed is 3. So you got -6. Okay. Now, you can also do that on the calculator. Again, parentheses -216, little caret key, parentheses 1 divided by 3, close it up, or using the X root button, putting the index in first. Okay with that? All right. Okay, now, so simplify each expression, assume that the variables can be any real number, and use absolute value symbols when necessary. Okay. So I want to review some rules. If you take the product of two powers with the same base, you add the exponents. So x cubed times x to the 7th is x to the 10th power. Y to the 4th times y squared is y to the 6th power. Okay, so there's that rule. Another rule, if you've got a power raised to a power, you multiply the exponents. So x cubed to the 4th power is x to the 12th power. Y squared to the 7th power is y to the 14th power. So you've got that rule. Okay. If you have a product raised to a power, you attach the outside exponent to each factor inside the product. So let's say I've got 4x, the quantity squared, that's 4 squared. Whoops, hang on, slow down here. That's 4 squared x squared, or 16x squared. And if you've got a quotient raised to a power, you attach the power to both the numerator and denominator of the quotient. So like if I've got 5 over y, the quantity cubed, that's 5 cubed over y cubed, or 125 over y cubed. So there's 4 rules. I'm going to go on and cover a few more here. Again, these are all back on that page, whatever page that was, 364, but it's back in section 5.2. Okay. Also, some of you that didn't get the corrected version of the loose leaf copy of the textbook, I believe that chapter 9 that I'm doing is chapter 8 in the one that you got originally. Look for the titles. The first section should have been radical expressions and radical functions. This is called rational exponents. Wait a minute. Yeah, that's right. Okay. I had one student that emailed me and wasn't sure what was going on there, so I just wanted to make sure. All right, there's some more rules. A to the 1 power equals a, so there's an implied 1 as an exponent. A to the 0 power equals the number 1. And finally, if you're dividing two powers with the same base, you subtract the bottom exponent from the top exponent. And this is all over 1, so it'd be like that. Okay. So, there's one more rule. There's always more rules. If you have something raised to a negative power, that's 1 over that same base to a positive power. Likewise, if you have this situation, you can rewrite it in this form. The idea being that typically you don't leave final answers with negative exponents. The exception would be scientific notation, and we're not dealing with that right now. So you've got, and I know that's a lot to take in. I'll review that as we go along here. Okay. So we've got the following. 25 a to the 8th to the 1/2 power. Again, it says simplify each expression. Assume that the variables can be any real number and use absolute value symbols when necessary. All right, so I have a product raised to a power. I'm going to attach that power to each factor of the product. Now, 25 to the 1/2 power, so that's like the square root of 25, which is 5. A power raised to a power, you would multiply the exponents. So a to the 8th to the 1/2 would be a to the 8/2 or a to the 4th power. Now, since the variable is raised to an even exponent, even if the variable was negative, a negative number raised to the 4th power is positive. So I don't need an absolute value on that answer. All right. Let's take a look at this problem. X squared to the 1/2 power. A power raised to a power, you would multiply the exponents, so we get x. However, in this case, we don't know whether x is positive or negative, so we do need absolute value bars. Okay. And then we've got this example, x cubed to the 1/3 power. That would be x to the 3/3 or x to the 1 or x. Now, in this case, I don't need absolute value bars. Since I'm taking an odd root, I can get a negative answer. Recall, if you're taking an even root, well, you can't take an even root of a negative number, and you can't get a negative answer when you take an even root, but you can take an odd root of a negative number and you can get a negative answer. Okay, so the restrictions are all there in terms of the even roots. Okay. How about this one? -16 q to the 4th power to the 1/2 power. So this would be -16 to the 1/2 power, q to the 4th to the 1/2 power. We're already in trouble because you can't take the square root of -16, so this is not real. Okay, it's not real. What about this one? So this would be -64 to the 1/3 power, t to the 9th to the 1/3 power. Is this one not real? No, it is real because we can take an odd root of a negative number. So this is like the cube root of -64, which is -4. Let's see, I mean, -64 is -4 times -4 times -4. So the cube root of -64 would be -4. And then this is going to be t to the what, 9/3 or t cubed. Don't need absolute value bars there because we're taking odd roots. Okay. How about this one? It says evaluate each expression. 27 to the 2/3 power. All right, now, if I had 27 squared to the 1/3 power, you could rewrite that as 27 to the 2/3 power, right? Because a power raised to a power, you'd multiply the exponents. But I can also go the other way. I can say 27 to the 2/3 power is 27 squared to the 1/3 power, or I could go 27 to the 1/3 power squared. In other words, I could do the power and then the root, or the root and then the power, as long as they both give you real results. Okay, since I'm taking an odd root, I don't have to worry about taking this even root of a negative number. Now, both of these will yield the same final answer. But if I do the 27 squared and take the 1/3 power, I can't do that one in my head, but I can do this one in my head, because the cube root of 27 is 3, and 3 squared is 9. But 27 squared is some humongous number, and then take the cube root of that. I'm not going to do that in my head. But point is, it looks something like this. Let's see, you've got a to the m over n power. You can write that as a to the m to the 1 over n, or a to the 1 over n to the m. You can do the power first and then the root, or the root first and then the power, as long as they both give you real results. And typically, you're going to want to do the root first. It's easier to take something, tear it down, make it smaller, and then build it back up than it is to take something and make it huge and then try and tear it down. Okay, all right, construction 101 here. All right, let's see. So I actually never did that problem. Well, yeah, I did do it. I did it right here. Okay. Negative 100 to the 3/2 power. Well, we're taking a square root, but be careful, the notation. This here, you'd be taking the square root of negative 100, and this would be not real. But here, the base is just that. If you want the negative sign included in the base, you have to group it. So this is basically -1 times 100 to the 3/2 power, which is -1 times the square root of 100 cubed, which is -1 times 10 cubed, -1 times 1000, which is -1000. And again, at any time, if I need to slow down, please yell at me. I'm not in any hurry. None of us are going anywhere. I mean, you know, all right. How about this one? It says simplify each expression. All variables represent positive real numbers. 27 a cubed b cubed to the 2/3 power. Okay, so that's 27 to the 2/3 power, a cubed to the 2/3 power, b cubed to the 2/3 power. So that's 27 to the 1/3 power squared. Okay, so I'm pulling that apart. And then let's see, a power raised to a power, you'd multiply the exponents. 3 times 2/3 would be 6/3 or 2. Power raised to a power, you'd multiply the exponents. 3 times 2/3 is 6/3 or 2. So I've got that. But 27 to the 1/3 power, the cube root of 27 is 3. But then that gets squared. So I've got 9a squared b squared. Okay. Let's see here. It says change each radical to an exponential expression. So I've got the 7th root of 7p squared q. So that would be the quantity 7p squared q to the 1/7 power. Okay, the index becomes the denominator of the exponent. The square root of x squared plus y squared would be the quantity x squared plus y squared to the 1/2 power. Recall there's an implied 2 as an index. Okay. This says change each exponential expression to a radical. I've got the quantity 6x cubed y to the 1/4 power. So that would be the 4th root of 6x cubed y. I've got x cubed plus y cubed to the 1/3 power. That would be the cube root of x cubed plus y cubed. I think I mentioned this before, but just a reminder, the radical is a grouping symbol. So I don't need parentheses around those because they're already grouped with the radical. Okay, now what about this one? 49 to the -1/2 power. So this is where we're going to rewrite it as 1/49 to the +1/2 power. But 49 to the 1/2 power is like the square root of 49, which is 7. 8 to the -1/3 power would be 1/8 to the 1/3 power, which is 1 over the cube root of 8, which is 2. So it's 7. Okay. You doing okay? All right. 25 over 49 to the -3/2 power would be 49 over 25 to the +3/2 power, right? Okay. Which is 49 to the 3/2 power over 25 to the 3/2 power, which is 49 to the 1/2 power cubed over 25 to the 1/2 power cubed. 49 to the 1/2 power is 7. So we get 7 cubed. 25 to the 1/2 power is 5. So we get 5 cubed. Let's see. 7 cubed, I think, is 343. Let me make sure. 7 cubed. Yeah. And 5 cubed is 125. And no, I didn't just calculate that quickly in my head. I've done it enough times to have memorized it. I still remember years ago, I took a physics class at YBC, and the instructor was doing all these, complicated problems on the board and taking roots and exponents and whipping out the answers. And we were all in awe until I realized he'd done the same problems over and over for 20 years. So it wasn't necessarily, not to say that he wasn't smart, he was, but I don't think he was recalculating it in his brain. I think he just had it memorized. Anyway, I was still impressed and blown away. But yes, Russ, what?
Yeah, I have to split because
Okay.
one of my other professor's office hours overlap with class.
How dare he do that?
I know. I just
Okay.
wanted to let you know why I'm signing out.
All right. I didn't scare you away with my story.
No, I'll
All right.
see you tomorrow.
Okay, take care.
Bye-bye.
All right. And carrying on here, let's see. Let's see, we've done that. We've done that. Let's take a look at this one. 4 to the 2/5 power times 4 to the 2/5 power. Okay, so a to the m times a to the n equals a to the m plus n. So this is going to be 4 to the 2/5 plus 2/5 power, which is 4 to the 4/5 power. Okay. How about this? 5 to the 1/3 power times 5 to the negative 5/3 power would be 5 to the 1/3 plus negative 5/3 power, which would be 5 to the negative 4/3 power, which would be 1/5 to the positive 4/3 power. Okay with that? Hopefully. Let's see. What about this one? 2 to the 5/6 power times 2 to the 1/3 power over 2 to the 1/2 power. So on top, I'm going to get 2 raised to the 5/6 plus 1/3 power. But I need to take 5/6 and add it to 1/3. The common denominator is going to be 6. So 5/6 stays 5/6. 1/3 gets multiplied by 2 over 2 to become 2/6, which gives me 7/6. So now I've got 2 to the 7/6 power over 2 to the 1/2 power. Okay. But dividing two powers with the same base, you subtract the bottom exponent from the top. So now I've got to deal with 7/6 minus 1/2, which would be 7/6 minus 3/6, getting a common denominator, which is 4/6, which reduces down to 2/3. So my final Jeopardy answer is 2 to the 2/3 power. We're having some fun now. Okay, let's see here. Distributive property. Let's see, we've got y to the 2/5 power times the quantity y to the negative 2/5 plus y to the 3/5 power. So distributing, I get y to the 2/5 power times y to the negative 2/5 plus y to the 2/5 power times y to the 3/5 power. Multiplying two powers with the same base, add the exponents. So this is y to the 2/5 plus negative 2/5, which is y to the 0, which is 1. This is y to the 2/5 plus 3/5, which is y to the 5/5, which is y to the 1, which is y. So final answer, 1 plus y. So again, you've got to know those properties of exponents to deal with this. This says use rational exponents to simplify each radical So basically, we're going to take this radical, we're going to rewrite it in exponential form, we're going to simplify it, and then we're going to change it back into a radical. Now, eventually, when you get comfortable with this, you can see that all I really did was reduce the 3/6 to a 1/2. Okay. How about this one? The 12th root of 13 to the 4th would be 13 to the 4/12, which is 13 to the 1/3, which is the cube root of 13. And let's see here. How about this one? The 6th root of x squared y squared. So that would be x squared y squared to the 1/6 power, which would be x squared to the 1/6, y squared to the 1/6, which would be x to the 2/6, y to the 2/6, which would be x to the 1/3, y to the 1/3, which would be x y to the 1/3, or the cube root of xy. So again, what am I doing? I'm reducing 2/6 and 2/6 to 1/3 and 1/3. Okay. Let's see here. How about this one? The 4th root of the square root of x. It says, use rational exponents to simplify each radical. All variables represent positive real numbers. So this would be the square root of x to the 1/4 power, which would be x to the 1/2 to the 1/4 power, which would be x to the 1/8 power, which would be the 8th root of x. Any questions there? Okay, well, that about does it for today. I think I've done enough to ruin your afternoon. So section 9.2 for tomorrow, and I will be back at 1:15 with an office hour if you have any questions. Otherwise, have a great rest of the day. I'm going to go ahead and stop the recording.